Hello guys, welcome to Rumta Solutions. Today we are looking at your hyperbola graphs. So just like we did with the quadratic, let's remind you of what you did in grade 10. Okay, let's remind you of what you did in grade 10. Remember in grade 10 you had hyperbolas in the form y equals to a over x plus q. And what you had said was, if this a is positive, your graph is between your first and your third. And if it's negative, it is between the second and fourth. Right? And we spoke of this guy as vertical asymptote. Was it vertical? It wasn't vertical asymptote. It was horizontal asymptote. Right? It was horizontal asymptote, which meant y is equal to q. On this line, you will then draw broken lines to say your function does not exist there. It also represented vertical shift, which was about shifting up or down. So we said if q is positive, the graph shifts up. If q is negative, the graph shifts down. And then we said here, by the way, your vertical asymptote, here your vertical asymptote, when I say here I mean in grade 10, your vertical asymptote was x equals 0, right? Your domain was x is an element of real numbers, but x is not equal to 0. Your range was y is an element of real numbers, but y is not equal to the value of q. Otherwise, you can also write it in this way. Your domain, you can say from negative infinity to 0, union 0, positive infinity. And your range, by the way, you say x is an element of, your range, you would say y is an element of, it's coming from negative infinity to q. Remember, it doesn't include the q, hence the normal brackets, then from q to positive infinity. But I prefer this one, right? I prefer these ones. They are super top notch. Okay, then you also spoke of your excess of symmetry. Let me squeeze it here. You also spoke of excess of symmetry. Remember, excess of symmetry divides the graph into two equal halves. It had y equals x plus q and y equals negative x plus q. These were our excess of symmetry equations, right? Now let's get to grade 11. Okay, this is all you did in grade 12. Let's get to grade 11. Now for your grade 11, we will say y equals a over x plus p plus q. Now p, we said it represents horizontal shift. Remember, I said when it comes to shift, it means the same thing as it meant in parabolas. When p is positive, it shifts to the left. When p is negative, it shifts to the right. P also represents vertical asymptote. asymptote. When you were in grade 10, your vertical asymptote was at x equals 0. But now because you are in grade 12, it is not, grade 11, the same thing will happen in grade 12. It is no longer x equals 0. But here it is equal to, x is equal to negative p. That's your vertical asymptote. Okay, that's your vertical asymptote. Now this p, the very same thing that I said in grade 11, sorry, in grade 10, same as in grade 10. So it's still, so when I say same as in grade 10, I'm gonna go back to the introduction slide. It still represents vertical asymptote. It still represents vertical shift. It's the same thing. Okay, it is the same thing. All right. Now, I think this is all we need. I want to show you an example. I'm just going to draw a graph, a simple graph. Let's say we have this graph here. And then we have this graph, we have this one here. This is -2, this is 3. Okay, so this graph looks like this, while this one looks like that. Here we can say our P is equal to 2. Remember, when P is 2, it has shifted to the left. So it has shifted to the left. Our Q is 3. So our graph would be y equals a over x plus 2 plus 3. Let's look at this one here. This one here would be, let's say this is -3, 2. This one here would be, as you can see here, P is equal to, here is it, remember P is your vertical asymptote, is equal to -2. Remember, when it's negative, it shifts to the right. And then what is Q? It has shifted down, so it will be -3. Our graph here would be y equals a over x minus 3 minus, oh sorry, -2, not -3, -2 minus 3. Do you guys see that? So when you finding your equation of a hyperbola, you look at these things and you will be able to find your P's and Q's. Okay, now without any waste of time, let's move on to your axis of symmetry. Now, axis of symmetry, remember in grade 10 you said y equals to x plus q plus minus, but now you will say y equals plus minus open bracket x plus p close plus q. In other words, this is y equals minus into x plus p, right, plus q, right? And then we have y equals positive, so it'll be x, maybe let me put it in this way, x plus p plus q. Of course, this is similar to saying y equals x plus p plus q. Okay, so these are the two formulas you use. So this one is one with a negative slope, right? And this one is one with a positive slope. So on your graph, whichever graph it may be, you have one like this, and then you have one like this. This is your one with the positive slope, and this is the one with your negative slope. Okay, this is the one with your positive slope, and this is the one with the negative slope. Okay, all right. Now we then let's head to domain and range. Domain and range. So the range remains what we had in grade 10. So I'm just going to give you an example here. Let's say it's like this, and then it's like this. So our domain, we will say, if you remember well, in grade 10, you said x is an element of real numbers, but x is not equal to a horizontal asymptote, sorry, vertical asymptote. So here, we said our vertical asymptote is our q value. So we'll say domain x is an element of a real number, but x is not equal to minus p. Our range will be y is an element of real numbers, but y is not equal to q. If you say this, you are done. Remember guys, highlight this. I believe this one you know from grade 10, right? So in grade 11 and 12, this is what you will be saying. X is an element of real numbers, but x is not equal to minus p. I don't like this one that says y is an element of negative infinity to negative p, and then negative p to positive infinity. I don't like it, but it's nice. So I prefer this one. It saves me time. Right? So this is it. This is your domain and range. So let me give you an example. E.g., determine the equations of the asymptote. Determine the equations of the asymptote. The axis of symmetry and the domain and range of the following. Graph 1, y equals 2 over x minus 2 plus 1. Graph 2, y equals 2 over x minus 2. Okay? Over 2 minus 2. Okay, x minus. Okay? Now, let's deal with number 1. Number 1 was y equals 2 over x minus 2 plus 1. Let me change the color. We know this is y equals a over x plus p plus q. This should tell you a is 2, meaning the graph is like this. And then p, as you can see, is equal to negative 2, meaning the graph shifts to the right. Q is equal to 1, meaning the graph shifts up. Now, the question says we must determine equations of the asymptote. So, for the asymptote, we will say x equals negative p, which is, what is negative? What is p? P is negative 2. So this is 2. What does it mean? This means x equals 2. Yes, x equals 2 because this graph has shifted to the right. Sorry, to the right. X is 2 to the right, right? Now, y equals q. What is q? Q is 1. So let's say y is equal to 1. We are done with the equations of the asymptote. Now, axis of symmetry. Now, with the axis of symmetry, we said y equals plus minus x plus p plus q, right? Okay, we have y equals plus minus x minus, we said p is minus 2. Minus 2, what is q? Q is 1. So when it's a positive slope, let's try it. X minus 2 plus 1. This means y equals x minus 2 minus 1. So y equals x minus 1. When it's a negative slope, y equals negative into x minus 2 plus 1. This is negative x plus 2 plus 1. This means y is equal to negative x plus 3. Do you guys see that? Great. Now we also need the domain and range, right? So domain, I said x is an element of real numbers, but x is not equal to minus p. Alright, if you remember, p is minus 2, so x is an element of real numbers, but x is not equal to 2. Right? Good. Range, y is an element of real numbers, but y is not equal to q. This is the formula you need to know. Right? So we'll say y is an element of real numbers, but y is not equal to 1. Right? Y is not equal to 1. Okay? And we are good to go. Okay. So I'm gonna leave number 2 for you guys. You can practice, but to give you a heads up, a is 2. Obviously, we tells you it is like this. P is 0. Q is negative 2. So you can do this one for number 2. You can answer this question for number 2. Alright? So have fun with this. Okay? Have fun with this. Now we're going to determine the equation of the hyperbola. Okay? We're going to determine the equation of a hyperbola. Let's get into it. Okay, finding equation. So with the hyperbola, the most important thing is for you to see if you are given asymptotes. Okay, let's say okay, let's do this. And then we also have this line. This is y, this is x, of course this is 0, and then this is 1, this is negative half. This line here is minus 2, and then there's another point here. Okay, so with this one, what we know is that we know that y equals a over x plus p plus q. My expectations of this question is that my a must be negative, my q must be positive. Right, let me not force it in this way. My q must be positive because it has shifted up, but I also see that my p is equal to negative 2. Not, is it negative 2? It is not negative 2. My p has shifted to the left, right, which makes it 2, right, because x value here is negative 2. So this means my p is negative 2. Remember I said to you, this is vertical asymptote, which you can say x equals negative p. So this is negative 2 equals negative p. Hence, p is positive 2. Alright? So, substituting into this, I will say, let me change the color. I will say, for now, let me say y equals a over x plus, it must be plus 2 plus q. I don't have q. Yes, I can see it's drawn here, but it's not given. So I'm going to use a point 0 and negative half if it's going to help. Let's see. We have negative half. Can it help? Okay, we have negative half equals a over 0 plus 2 plus q. What do we have? We have negative half equals a, because it's not a, it's a over 2 plus q. Alright, so what do we have? We have minus 1, not minus 2. We have minus 1 equals a plus 2q. Right? Cool. I'll come back to this. Maybe I can call it equation 1. Maybe I can call it equation 1. Now I'm going to try this point 0 and 1 and 0. Let's try it. So at point 1 and 0, where there's x we put 0, where there's y, where there's x we put 1, where there's x we put 0. Where there's x we put 1, where there's y we put 0. So this is a over 1 plus 2 plus q. What do we have? We have 0 over a over 3 plus q. Multiplying by 3 throughout, we can say 0 equals a plus 3q. So let's call this one equation 2. Let me remind myself what was equation 1. So equation 1 was this. So how about I say equation 2 minus equation 1. So equation 2 minus equation 1, what do we have? We have this guy equals a plus 3q minus 1 minus 1 equals a minus, a plus 2q, isn't it? Yes. So I'm going to put it in this way. So if I said that 0 minus 1 is 1. 1 minus, a minus a is, a minus a is 0. Alright, a minus a is 0. 3q minus 2q, what do we have? We have q. So q is 1. Right? So q is 1. Now, having said that q is 1, we can substitute this value on either equation 1 or 2. So let's see, on either equation 1 or 2. So we can say 0 equals a plus 3 into 1, right? 3 into 1. This implies 0 equals a plus 3. This means a equals minus 3, right? This means a equals minus 3. Let's check our graph. Looking at the graph, yes, I expect my a to be negative. I expect my q to be positive. Indeed, it is what I found. Q is positive, a is negative. Therefore, we have y equals negative 3 over x plus 2 plus 1. And we are done. Alright, guys? So, this is how you do your hyperbolic expressions or hyperbola graphs. Okay? So, with that being said, it's a wrap. See you next time. Bye bye.